All right, so this first one says find dy dx, so that means find the derivative. It's derivative of y with respect to x is what that is officially saying there, but it means find the derivative. So for this one, we're going to need a chain rule. It is a composite function. The outside function is the power that's squared, and the inside function is all the stuff in parentheses. So dy dx equals, we're going to do a power rule. So bring the 2 down, and it's going to drop to a 1. You don't have to write the 1 if you don't want to. It's not going to be written in any of the answer choices, but if it helps you remember that you did the power rule, you can put that there. And then all the inside stuff is going to just stay the same. The guts of the problem, you just copy that over. And then we're going to chain on the derivative of the stuff inside, which would be 3x squared. The plus 1 is a constant, so that is gone. And then we're looking for which choice matches this. What they did is they multiplied these together and got the 6x squared that's out front, and then times the x cubed plus 1. So that one is E. All right, the second one, they give us this graph of f of x. So f of x is linear, and then g of x is a parabola, it looks like, but some sort of curve. And they drew in 2 of the tangent lines for g of x. So they gave us all that. And then they tell us b of x equals, I'm going to write this bigger because it's kind of small here, g of f of x. And they want b prime of -3. Okay, so first we're going to find b prime of x, and then we're going to plug in -3 and see what we get. So this would be another chain rule. G is the outside function, f is the inside function. So remember I said don't get hung up on what they're calling them, like f and g. Think of them as outside and inside, because they can switch them around like they did here, or rename them entirely like they do sometimes. It'll be like Q and R, so don't get hung up on the letters. We're going to do derivative of the outside, leave the inside alone, and then chain on the derivative of the inside. So plugging in -3, we're going to start here. We'll do f of -3, and whatever we get, we're going to do g prime of that. So f of -3, f of x was this line. So at -3, we're right here. And so f of -3 is 1. So I know that this part is 1. And then we're going to do g prime of that. So g prime of 1. So remember, derivative means slope, slope of the tangent line. And so here is 1 at g, and they drew in that tangent line for us. We just need the slope of that tangent line. And it appears to be going down 1 over 2. So that means a slope of -0.5. So again, just remember, derivative means slope. So we found the slope of that tangent line. And then times f prime of -3, and we're still plugging in -3 here. So f prime of -3. So we want the slope of f at -3. It actually doesn't even matter that it's at -3 because f is linear. It would have the same slope no matter what point you were at. But it appears this line is going up 1 over 3, up 1 over 3. So that would be a slope of 1/3. And if we multiply those together, we will get -1/6. So that one is B. So again, derivative means slope. All right, this one is a chart problem. I'll try to zoom in some more here. It says table gives values, differentiable functions f and g, and f prime and g prime. It says h of x equals, again, I'll write this bigger here, f of g of x. This is going to be another chain rule. It says, what is the slope of the graph? And again, that means derivative at 2. So we are going to find this derivative, and then we're going to plug in 2. So we're going to find h prime, and then we're going to plug in 2. So again, chain rule, we're going to do the derivative of the outside, so f prime, and leave the inside alone. and then we will chain on the derivative of the inside. And we're going to evaluate this at 2. So first we're going to do g of 2, and whatever we get, we'll do f prime of that. So using the chart, let me ask you guys, you see that chart well enough? Go ahead and type in the chat, what is g of 2? We want to evaluate these. G of 2. Good. That one is -1. Just want to ask you guys some questions so it's not just me talking at you the whole time. Also, I want to check that you can read the chart. All right, and then we would want to do f prime of -1. So find that on the chart for me. What is f prime of -1 going to be? Perfect, good. F prime of -1 will give us 3. So this first part's 3. And then we want g prime of 2. Again, we're still plugging in 2. So guys, find g prime of 2. Good. G prime of 2 will be 2. So 3 times 2 gives us 6. And so our answer is D. All right, number 4, we're given this absolute value function. We want the derivative at 3. I would draw a picture of it. This is an absolute value graph shifted right 3 and up 2. So if we go right 3 and up 2, our graph will look something like that. And they want the derivative at 3. Well, here's 3. We cannot get a derivative there. Why not? Just by typing in the chat, what is the problem at 3? Why can't we get a derivative there? Yeah, perfect, good. There is a sharp edge, so we are not differentiable, and so this one will be E. All right, number 5, it says write an equation. That means I need a point and a slope. And they gave us the whole point, 1, -1. So I didn't even need to plug in for that. They gave us the whole point. That was good. Slope comes from the derivative. So I'm going to want the derivative at 1. So that means we need to find the derivative of this function. Now this is going to be a product rule. I've got my colors and color code this. X is the first function. And then all this stuff in parentheses cubed is the second function. So this is going to be a product rule. So product rule says we want the first function, so that's just x, times derivative of the second. So we're going to do the derivative of this part that's underlined in green. Now that is going to involve a chain rule, so this part's going to be longer. We're going to bring the 3 down. It'll drop to a 2. The insides are going to stay the same. And then we're going to chain on the derivative of that inside part. Now 1 is a constant, so that's going to be gone. Derivative of -2x will be -2. So this was first times derivative of the second. And the reason that was so long is because there was a chain rule. Plus the second function times derivative of the first. So hey guys, what is the derivative of just plain x? Yeah, good, that's just gonna be 1, because it's 1x to the first, so that would just be 1. So you actually don't even need to write that if you don't want to, but just to show the whole product rule, it's first derivative of the second plus second derivative of the first. All right, and we wanna plug in 1. So if we plug in 1 for x, okay, that's 1, so we can kind of ignore that. This would be 1 minus 2, which would be -1, squared would be +1. So all of this is going to be 1, times 3 would be 3, times -2 would be -6. So this first part is -6 plus And then if we plug in 1 here, we're going to have -1 cubed, which would be -1. And so my slope is -7. So this is my point, this is my slope. I'm going to put it together into the equation. It'll be y minus -1, so that'll be y plus 1 equals the slope, and then x minus 1. Now, they rearranged all of these so that they're all y equals, so I'm going to have to keep going here. So it'll be y plus 1 equals -7x plus 7, and then subtract the 1. So it's not difficult, but you just had a few more steps there to be able to pick your answer because they simplified it all the way. And so that one would be A. All right, so this one again, asking for dy dx, that means the derivative. Which rule do we need for this one? Good, that will be quotient rule. All right, so derivative equals, quotient rule starts with the denominator, so 3x plus 2. So denominator times derivative of the numerator would just be 2, minus the numerator times derivative of the denominator, which would just be 3, over the denominator squared. And once again, do not cancel these out. You cannot do that. But to simplify this down, we're going to do algebra. This is all your algebra steps here. We're going to distribute and combine like terms. So distributing this 2, that'll give us 6x plus 4. And then over here, we're not just distributing a 3, we're also distributing a negative. So we are distributing a -3 through these parentheses. So that will be minus 6x minus 9. And the denominator is not changing, so just bringing that along. And then these 6x's are going to cancel. And so my numerator 4 minus 9, that'll be -5. So I'm looking for -5 over 3x plus 2 squared. So that would be D. All right, 7. What is the instantaneous rate of change? All right, remember, instantaneous rate of change means derivative. So they're asking for the derivative at 2. So we're going to find this derivative, f prime, and then we're going to plug in 2. So this is going to be another quotient rule. So that's the denominator times derivative of the numerator, which would be 2x, minus the numerator times derivative of the denominator, which would just be 1, over the denominator squared. And we're going to plug 2 in for x. So let's see what that gives us. 2 minus 1 would be 1. 2 times 2 is 4. So that first part is going to be 4 minus, all right, 2 squared would be 4, minus 2 would be 2. And then over 2 minus 1 would be 1, squared would be 1. So my answer is 2. So that one is D. And then last one, we have a piecewise function. C and D are constants. That means they are just some number. F is differentiable. Okay, guys, if the function is differentiable, we know that it is also what? If it's differentiable, what is it also going to have to be? Yeah, good. This means that it is also continuous. If your function is differentiable, it's also going to be continuous. So that means that these two pieces are going to link up. So I'm going to start by setting them equal. So if I know the two pieces are going to link up, I'm going to set them equal. And then it said at x equals 2. So I'm going to plug in 2 for x. So this would be c times 2. So 2c plus d equals 2 squared would be 4. minus, and then again, if x is 2, this would be 2c. The best I can really do here is get the c's together. If I add over 2c, I'm going to have 4c plus d equals 4. But then I'm kind of stuck because I have two variables and that's not enough information. So I'm going to move over here and we're going to keep going, try something else. I'm kind of roadblocked there, so I'm going to leave that for a second. That's the function being continuous. I just set the two pieces equal. If the function is differentiable, then I know the derivatives match up as well. So I'm going to set the derivatives equal 2. So derivative of cx would just be c. Kind of like derivative of 3x would be 3. Derivative of 4x would be 4. So derivative of cx would just be c. D is a constant, so that's gone. Equals, and then if I do this derivative, that would be 2x minus c. So here I just set the functions equal because we're going to be continuous. Here I set the derivatives equal because we're differentiable. And again, this is at x equals 2. So I'm going to plug in 2 for x here, and that will give me 4 minus c. And then if I add this c over, I will have 2c equals 4. And so c is 2. So I know that c is 2. If I plug that in on this equation, that will give me 4 times 2 is 8. And then subtract the 8 over, so d is -4. And then what they asked us to do is add those together. It says add c plus d. So if you add those together, you're going to get -2. So that one is b.